Hello everyone. In this video, we are gonna apply whatever knowledge we have gained in our previous video about the decision tree, the maths behind that, and so we are gonna apply all those things in our Python code and work on ML decision tree implementation. Basically, we call it implementation because we are not gonna use any sklearn library. We are gonna directly apply all the associated maths through raw code, and just this is basically to understand what actually happens inside the sklearn module when we call the decision tree regressor or classifier modules. So let us just start. So we import the basic libraries of maths and log2, then we import pandas spd and numpy. So as you know, entropy calculation requires log base 2 basically. So we will actually work with both or gate and as well as the iris tree. So let us first divide the x train y train of the or truth table. So you can just write the or truth table in a excel format and save it in the csv file extension, and then you can keep it in the same directory, and from pandas.read underscore csv you can just store the data frame in a variable. So now we create something known as count function. So this function will basically return the list of unique values of the corresponding classes. So suppose your y values, so you can see the y values are here, so y train values basically. So whatever values of y will be there, it will see how many unique of them are there. Suppose 3 unique values are there, then it will count how many unique values of each class are present. So here in case it is 3, and for each class it is 50 unique values are there. So total 150 rows. It may be arranged in a random order, but each class are having 50 count, and there are 3 unique classes. So we just count unique would store the 50 50 50, and the unique values would store each and unique value. So you can understand what we have to do. Basically we have to just traverse through our y, and if value is not in unique values, and then only we append. So this makes sure that the value which we are using is not already contained in the list of unique values. So for unique in unique values, we initialize the variable count as 0 for because we want to count the number of unique values. So for value in y, if y equals value equals to unique, count plus equals to 1. So if the unique we are basically, for value in y means we are again traversing through our past y argument, and we are seeing how many of them belongs to unique, and we are just increasing the count, and at the end we are just appending the count value. So we just return two of those lists through this function. Now the definition of check pure function, this is quite simple. It just returns a boolean value. So it just check whether the node is pure or not. So if you recall what is actually a pure node, so the node in which we don't have to do any kind of majority voting, the majority of classes is clear in front of you. So that is possible only if the 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 all of other classes count is 0. So an example you can see here, 23 0 0. So if you notice one thing here, the length of the list is 3, so number of zeros is 2. So even if there are a large number of classes, let's say 5 classes, so number of zeros should be 4, because only one class should be dominant, and that's basically what we call as a pure node. So we can just you have understood, I think, the concept. So we can just iterate through the values and just check whether num0 is equals to len of unique values minus 1 or not, and then return true. Otherwise we should return false in any other case. So this function basically checks whether a node is pure or not, and this function is basically calculating the entropy value. So if you remember the entropy formula from our previous videos, it's the current value divided by the sum multiplied by the log base 2 of I by sum. So So first we calculate the sum of all the count unique, and then we just apply the formula. So this we only do if I is not equals to 0, otherwise there would be a math domain error, you can see. And also from the concept you can understand that entropy, when our observation is 0, it does not contribute anything to the entropy, so we can simply add the value 0. And so why we are using these formulas, and what is the essence behind it, why we are not simply using accuracy, all this I have clearly explained in my previous videos of the decision tree. So here we are just applying whatever formulas we have run. So I will just suggest you can go through my previous videos and just or you can just search Google and just note down the formulas in your copy, the entropy and all those formulas of information gain ratio, split in force. So all those you can just note down in the copy. So through this video throughout this video it will be easier for you to follow. So now we create another function which basically calculates the gain ratio. So we have the xtrain, ytrain and past feature f. So it calculates the gain ratio if the if we are deciding to split upon a particular feature f. So in the concept of decision tree, I have clearly explained you that we first need to decide what feature we are gonna use to split upon. So that feature would be the one with the maximum accuracy or with the maximum gain ratio. That feature we will use particularly. So this is a part of our greedy algorithm, which says that split the feature first, which gives the maximum accuracy. So we are going to use that algorithm. So first we are doing count of ytrain. So we are just getting the unique values and the count unique. So then we are just merging, concatenating the data frame of xtrain, ytrain and creating one entire data set. Of course we are concatenating through the y-axis, which is denoted by the axis equals to 1. And the features is basically the name of the columns. We extract the name of the columns through here and store it in a list, and we just add another column y. So this contains basically the xtrain name of columns, but the final value of y also we need to store it in the last column basically. So this will be stored at the last column, and the total df dot columns is assignment equals to column. So what does this mean basically? So we are just setting the columns names for the future access. So this our column variable contains the list of all the column names. So those column names we are assigning to our original total data frame. So we are just setting that column names for our future easy access. So you also know that we need to calculate the weighted mean entropy. So as to get the gain ratio in future, so we initiate a variable with 0. So in the information gain formula also it is required, and we initiate another list variable which would basically store suppose the number of elements in the splitted class. Suppose in the class which is obtained after splitting. So suppose a 50 size class is splitted into 25, 15 and 10. So it will just show the count of each class. So for I in unique values, now we iterate. Now you see here I have imposed two conditions. What are those two conditions you need to be careful about? So total data frame of f, what does this mean? We are selecting those features which are passed in our function, and equals to I means our features must also be corresponding to our current iterating values. So for I in unique values, so you try to understand that what values will exactly I take. I will take basically the three values, only the three classes values. So first we are telling that our feature what are the feature f. They can be, suppose for iris dataset they can be petal and petal width, sepal and sepal width. So suppose any of those features which I decided to split upon should also correspond to the class of the flower which I am traversing. So that will be my new y new. So that the last column of that will be my y new basically, because you can see the first argument specify all the rows, and the last the second argument specifies which column. So we have the y new with us now. Now the new unique values and count unique, we just do it by count, and then we just find the sum of all the count new count unique. Why we are doing this? Because we need to find the weighted mean entropy, which is easily calculated by sum by len of y train into entropy of count unit. So I told you that you must have the formulas written on your copies for easy understanding of this code, or if you remember it directly from my previous videos, so that would also work. And so the information gain what we obtain is also from the formula of entropy of count unique. So we just apply the entropy formula for our list of count unique and then subtract the weighted mean entropy. We are just applying the formula whatever we have learned, and split info is basically also the entropy of the list of sum. So the whatever the classes count we have obtained after splitting, that is the split info. Those entropy if we calculate, that is known as the split info. So gain ratio, it is the information gained by split info. So you also need to take care that the denominator is not 0. So you have to implement a condition of check there, and then only calculate the gain ratio and return that. Otherwise you can return it as 0. So every time the split info will be 0, the gain ratio would also be 0. Okay, so now we implement our main decision tree function, which takes the x-train, y-train features and level. So first what we are doing is we are selecting the list of features. Now what we would do basically is whichever feature we are splitting upon, we will subtract that feature, we will delete that feature from this list of features. So this list of features specifies which features are still left to split upon. Once we use those features, we will just remove it from our list. Then we use the count function again to calculate the unique values and count unique, and then we also store the maximum index of the count unique. So why we are doing this, you will easily understand that this is basically we are doing for the majority voting. Suppose the index of the maximum value of the count unique would be taken for majority voting if we do not have any features to split upon further. So first we are defining the base cases. So the first base case would be to check whether my current node is pure or not. So if my node is pure already, so we can just print reach leaf node. So what is this print always? So this print always is basically a function which I haven't shown here, but you can easily create this. It will take the count unique values and level, and it will just print it in a specific format. So what is the format? Here is the output of format of the output, the level, the count of 1, the count of 0, the entropy, and the splitting on feature will get this, and those steps you need to just print. So that function will basically print it again and again. So there are some things which you need to print always. So you need to always print the level, you need to always print the level, you need to always print the value of count, and the entropy also you need to print always. So you can just use that function so to save your time basically. So where we were, yeah. So we check whether our current node is pure or not, and if that is pure, we just say that we have reached the leaf node. And if our len of features equals to 0, what does this mean? So it means that we still haven't reached the pure node, but we have exhausted our features, so we do not have any remaining features to split upon. Okay, so what we would do basically, then we will just implement the majority voting. So unique values of index is measured with count of something. So index was basically the maximum value of the count unique. So the maximum value of is already selected for the majority voting, so we just print that. Otherwise we use the recursive function. So in the decision tree, it is easy to catch that the first node we split it upon, suppose, into 3 nodes, and then the further splits is similar to what we have done in the first step, that is splitting it again and then again. So we would just implement a recursive function in the else in the else clause. So now we do, after print always, we just create a list of gain values. So we gain ratio values, we create a list, and from our gain function we would easily get the gain ratios. So for f in features, we get the gain list of append. So we are just appending the gain ratios if we split upon a particular feature f. So whichever will be our maximum gain obtained in the list, that will be our gain ratio, and the that gain ratio is present in a particular element of the list. So that element, that index of the that element of the list would give us which feature to split upon actually. So we just create another variable of apt feature, that which feature we need to split upon. So the features of gain list of index of gain ratio, you can easily understand that the gain ratio is present in whatever index of the gain list we have obtained that by splitting upon that particular feature. So first, suppose in the gain list the first value is the maximum, then the first feature we need to split upon. Similarly, if the third value is the maximum, then the third feature we need to split upon. So that whatever index value is the maximum, that index value of the features we need to split upon, and that would be our appropriate feature basically. So we print that splitting on feature with apt feature with gain ratio, just this. And then we again create a data frame by concatenating the x train y train value along the column axis, and then we remove the app feature because we have already splitted that. So our split we just remove that, and we just using the app feature then we do the splitting. So you count your then again the same thing we are doing with the unique with the appropriate feature values. We are just counting the total data frame whatever is there in the appropriate values. So for value in unique values of appropriate, so for each values in the appropriate value obtained by splitting in the feature, we are creating x new and y new. So here we are basically doing the split. So x new is the new node, y new is also the new node, x and y values of the new node. So we are just calling the recursive function again so as to behave similarly, just the level is one increased. So you can easily understand that this, I hope. So the app feature value we extract it from the database, and also our value should be of course equal to that because of our iterating value. And then we whatever the same technique we use for the x and y splitting, we do it here also, ilog using the ilog function, and then we normally call our recursive function. So you can see the this is basically for the OR table or truth table. You can see that the level 0, the count of 1 is 3, count of 0 is 1. So splitting on feature x with gain ratio is something this. So you can just go through the output and try to understand what is exactly happening. So this is the initial node, this is the second level node, these are two other second level node, and level 2 means the third hierarchy of nodes. So from we can just use this same thing to work on the iris dataset. So we just import dataset from sklearn, and we basically split it into x train and y train. And you also know that the type of the y values should be 0, 1 and 2, because of course those string data types cannot be handled by the model during the execution. So we are basically decorating our final y values with the final names of the flowers. So if code is 0, we name is at Setosa, and 1 for Virginica, and the second code for code number 2 for versicolor. So you just create a function and just apply the function using the apply feature along the column axis. So you finally get the data frame looking something like this. So you have the df of one column. So before this the data frame looks something like this. It had no column names and nothing, only 0 and 0, 1 and 2 classes. Now you have all the flower names as well as the sepal and sepal with petal and petal with. So now you create the x train and the y train values by separating using the same strategy whatever we have done, and basically you can run the decision tree in the same way exactly as you have done in the OR tree to create the decision tree of this iris dataset. So this decision tree is a really simple model because it does not use pruning, and this so actually it's simpler to write, but the decision tree will contain a lot of level. You can just open it in a text editor and view. So it will be a really complex decision tree without any pruning, and so this decision tree would be huge and complex. This makes your concept further clear about how exactly the things are working and how to code that in the Python, and how exactly the sklearn what you in the sklearn module, how the stuffs actually work, you get to understand through this video. So yeah, thanks a lot, and from the next video onwards we will start random forest. So till then, take care.